today we will start with the second part of the tunneling lecture, and in this part we will discuss different tunneling methods in the firm ground and in the rocky strata. Number one, we will discuss the tunneling in the firm ground. There are multiple methods for the tunneling in the firm ground, in which includes the first method, which is the full face method. The full face method is a tunnel excavation technique where the entire tunnel face is excavated simultaneously without dividing it into the smaller sections. This method is also known as full face tunneling or full face excavation method. Now when we have the firm ground, which is also known as stable ground, we don't have to pay so much attention towards the safety of the excavation. We don't have to pay too much attention towards the safety during the excavation, because we know that the ground is firm, and then we only have to need the shotcrete for or the lining in the tunnel after the excavation. Full face method is generally applicable in only the firm soils where the full face excavation can hold it itself for the sufficient time to allow mucking and supporting operations. Now mucking and supporting operations generally means that mucking means to pull out the excavated material which fall into the excavation site, or generally we can say a tunnel site. And the supporting operations are the operations where we have to put the supports in the tunnel to hold the falling material from the tunnel. In the full face method, workers excavate the entire diameter of the tunnel at the same time. This is the most suitable for tunnel passing through strong ground for building smaller tunnels. The characteristics of the full face method are it generally is a simultaneous excavation. It requires less time, no division into smaller sections or headings. Number 3 is that single stage excavation process. Number 4, faster excavation rates compared to other method. It is a cheaper method. Number 5, it has improved tunnel geometry and accuracy. This is a tunnel boring machine, TBM, and it excavates the tunnel. It is a visual application. It is a visual demonstration of the tunnel boring machine. Then this is the finished form of a tunnel. Now it is a second method of the tunneling, but it is generally or it is generally applicable where there is not the firm ground. This method name is top heading and benching. When full face excavation is not possible, where it is not stable ground or stable soil, or when we have faults and folds in the rocky strata, then we will not focus on the previous method, which is of the full face method. We will now focus on top heading and benching method. In these techniques, worker digs a smaller tunnel known as a heading. Once the top heading has advanced some distance into the rock, workers begin excavating immediately below the floor of the top heading. This is a bench. One advantage of the top heading and bench method is that engineers can use the heading tunnel to gauge the stability of rock before moving forward with the project. This is a visual demonstration of how we use top heading and bench method. First we will dig our tunnel in the top heading. Then we will have a step which is known as a bench. It will called as a bench 1. Then we have the second bench. We will call it a bench 2. In this way the whole tunnel is dig. Now the third method we have is a drift method. In case of large or pilot tunnel, drift is made and then expanded. There can be more than one drift. Different drift methods depending on location of drift can be used. In this method, we will have the first operation as the lower drift operation. Here, then we have to dig the upper drift portion here. Then we have the third portion here, and then we have the fourth portion, and we will interconnect these with each other. Now the fifth operation is to transmit the side pressure to core until main tunnel ribs are placed. These are the main tunnel ribs, and then we have to give the interliner, which gives the support for avoiding the mucking, and then these design concrete line. This is the dry packing, and then we have to give a drain. Now tunneling in soft strata. Tunneling in soft strata refers to excavation of tunnels in soil or rock conditions that are soft, weak or unstable. Soft strata can include clay, silt, sand or loose gravel or weak rock. Weak rock can be shale or any sedimentary rock, or we have some metamorphic rock as well. Tunnels constructed in soft materials require temporary support immediately or shortly after excavation. Way to provide supports are suitable spaced bands of wood, suitably spaced bands of steel for legging, which is also known as converging, liner plates, which is of prefabricated concrete, and four poling placed to retain material between adjacent bends. Temporary support must be designed for higher working stress compared to those in permanent designs. Instantaneous support is required. We have to give instantaneous support in the soft ground, no drilling and blasting, because when we have the firm ground, we can't drill and blast because it will fall immediately. Now the method here we use is the method of four poling. Four poling generally refer to as inserting a sheet which is known as a rib, and then we give the further lining in the tunnel to make it stable. Four pole act as cantilevers beyond breasting. Soil is excavated after removing the breastboard and new rib is erected. Now moving further, we will have the considerations why we use the four poling and constructing the tunnel in a firm ground. Because standard time is generally short when we're tunneling through the soft ground. Cave instead are a constant thread, means it will fall instantaneously into the tunnel, and we will not able to for the mucking and supporting reactions. To prevent this from happening, engineer use a special piece of equipment called a shield. A shield is an iron or steel cylinder literally pushed into the soft soil. It carves a perfectly round hole and supports the surrounding earth while workers remove the debris and install a permanent lining made of cast iron or precast concrete. When the worker complete a section, jack push the shield forward and then repeat the process. Here we can see the Brunel shield. It is a shield which is inserted in the tunnel. Then it has multiple sections. Here we have first section where three workers are working. They are giving the supports for the tunnel, which is necessary for the safe operations. These are the breasting boards. Tunneling in running ground. Running ground refers to the excessive groundwater table conditions where we can't dig or drift in the rocky strata or soil. Where we have the groundwater table conditions near the tunnel, we have the running ground. Many methods we have elaborated for the running ground conditions. Principle is linear plates are pushed in starting from the ground. Cavity is excavated. Additional linear plates are pushed one by one and bolted. Tunneling in rocks. Tunnels are driven in rock by drilling holes in the rock face, loading the holes with the explosives, blasting and removing the broken rock. Each sequence full cross section of the tunnel may be excavated or one or more drifts may be there. Drilling pattern for holes of explosives may differ depending upon rock type. Either it is a metamorphic rock or a igneous rock, which is a strongest rock, or a sedimentary rock. Cross section, experience, expertise, and the other types of explosives suggested. The methods here for the tunneling in rocks are full face method, the top heading and benching method, the drift method. Tunneling through hard rock almost always involves blasting. Workers use a scaffold called a jumbo to place the explosive quickly and safely. The jumbo moves to the face of tunnel and drills mounted to the jumbo make several holes into the rock. The depth of the holes can vary depending on the type of the rock, but a typical hole is about 10 feet deep and only a few inches in diameter. Next, workers pack explosive into the holes, evacuate the tunnel and denote the charges. After evacuating out the noxious fumes created during the explosion, we also know that the explosion causes toxic fumes into the tunnel, which is necessary to be pulled out for the safety of the workers and for their lives. Workers can enter and begin carrying out the debris known as muck using carts. Then they repeat the process with the which advances the tunnel slowly through the rock. It is the process of jumbo, in which we use jumbo for drilling and explosive and carrying out the excavation of tunnel. Then further on we have the tunnel boring machine. We can use it also for loading the explosive into the tunnel for the further excavation processes. Now the second method for the excavation of a tunnel in rocky strata is fire setting. Fire setting is an alternative to blasting. In this technique, the tunnel wall is heated with fire and then cooled with water. The rapid expansion and contraction caused by the expansion and contraction caused by the sudden temperature change causes large chunks of rock to break off. The Cloaqua Maxima, one of the room's oldest sewer tunnels, was built using this technique. The stand-up time for solid, very hard rock may measure in centuries. In this environment, extra support for the tunnel roof and walls may not be required. However, most tunnels pass through a rock that contains breaks or pockets of fractured rocks, so engineers must add additional support in the form of bolts, sprayed concrete, or rings of steel beams. In most cases, they add a permanent concrete lining. Moving further, we have a sequence of operation in rocky strata: drill and blast, marking tunnel profile, setting up drilling, loading explosive and blasting, removing the foul gases, checking, scaling, mucking, and at the last rock bolting and lining, which is for the stability of the tunnel. Now we have different construction methods for carrying out process of excavating and constructing our tunnel. Number one is drill and blast, which I have discussed earlier. Mechanical drilling, which is cutting. Cut and cover, we have also discussed it earlier. Immersed tunnels, it is a type of tunnel that is constructed by building prefabricated sections on land, transported them to the site, and then sinking them into the place in a trench excavated in sea floor or river bed. Moving further, we have a tunnel boring machine, which we have seen in earlier slides. New Austrian tunneling method is a different method which is also known as the sequential excavation method or spread concrete lining method. Then we have these road headers which we use to excavate a tunnel. Then this is the visual demonstration of a tunnel boring machine, which is huge in size, which can be seen in this picture. It is an example of visual example of tunnel boring machine which is inserted for the excavation, and here are the soldier piles, which is for the stability of the rocky or soil strata.